I'm going to graph this one in red. Do you remember, before I do that, do you remember me talking about, at the very beginning, that logs and exponentials are inverses? Remember that? Okay. So this is an exponential, which means if I have its inverse, it would look like that. Why? Because inverses are mirrored over the line y equals x. So if this is an exponential in light blue, then in the purple I have a
logarithm.
Logarithm. Very good, Joe. I have a logarithm. And if we know in light blue that this point was 0, 1, then in purple this point has to be 1, 0. Because domains and ranges switch. X's and Y's switch for inverses. Notice how the asymptote is the x-axis for the exponential, and the y-axis is the asymptote for the logarithm. Okay? All this stuff ties together like a puzzle. So in the red now, if I look at a logarithm, the general logarithm graph, no matter what its base is, looks the same. Looks like this. And always has the intercept of 1, 0, unless it's been transformed. Meaning moved left, right, up, down, stretch, shrunk, something like that. So now let's talk about the transformations. So in the red, that's the regular log graph. They chose base 10. Who cares what it is? Could have been base 13. Let's now look at what happens if I do the second one. X plus 2. What happened to that graph?
It moves to the left.
It moves left 2. So what I want you to notice before I do that is that this graph, the logarithm in red, had a vertical asymptote at x equal to 0. If I move it to the left 2, my new graph should have a vertical asymptote of, I would say x equals negative 2, because it moved 2 to the left. Yes, the new intercept in gray is going to be at negative 1. That is correct. I agree. Which means that the new asymptote has to be to the left of that, right? Because it's going to hit after that. So here's my new asymptote, and that is the vertical asymptote of negative 2. Again, all this kind of ties together. So if you kind of get how one thing moves, everything's moving. Not just the intercept is moving 2 to the left, but so is the asymptote. The last one that's highlighted in orange not only moved 2 to the left, it also moved 1 down. So we're just going to drop it by 1, so 2 to the left, and then 1 down. Oh, only 2 to the left, 1 down, so here's where that is. Did the asymptote change?
No.
No.
Don't you go off the original graph?
It's always off the original. 2 to the left, 1, 2, and 1 down. Yes, that is correct. Now, I don't know where it's crossing exactly on the x-axis. I could probably figure that out, I suppose, if I wanted to. 1, into the 0, 2, somewhere over there. I don't know. But I do know that my vertical asymptote has not changed because I've only moved to the left 2. And moving up and down doesn't change the asymptote. So I still know that my vertical asymptote is at x equals negative 2. I just want you to see kind of what's happening with these graphs. Shut up.
I had brothers.
I had brothers. I have brothers. Brothers! Brothers and sisters, lend me your ears. Joe, I didn't even say anything yet. It's on video now, Joe. What's different about this stuff that you see right now and that stuff?
LN.
LN, which means you're talking about?
Something different.
Linear.
Not linear.
Log of a number. Log of a number.
Line.
Logarithm.
Natural logs. I told you yesterday
Why
that
don't they put n?
the letter E, that irrational number, 2.718, is a very important number.
That's confusing.
Look on your calculator.
You should put
Look on your
n.
calculator.
What? Oh, no, no. LN.
You see LN down there. See LN?
Yeah.
When you see LN, they're talking about log base E. So we have two bases that we work with all the time. They are the only two bases that your calculator can do. So you can work with log base 10, and we always write it as just log. Done. You can also work with log, is on your calculator, base E. But we don't write it as log base E. We write it as ln, log natural. So if you ever see ln, that's what it means. These rules are the exact same rules that I just showed you how to do. Except the base is
3.
E.
Oh, yeah.
Natural E.
3. E. A little less than.
Dang.
No, no.
Should I do some more numerical representations of what's happening? Would you like to see that? Or no?
Yeah, sure.
All raise your hand if you want yes. Okay, we'll just do it then. Nike. Number 1. The log. Actually, I don't know that I can put any numbers in here in all honesty. They already do it. Yeah, I don't really know that I can do that. So let me point some things out. I don't know if that's going to work. Let's look at number 2 actually. What do you know about logs and exponentials?
Cancel each other.
They cancel each other. So if I were to rewrite number 2 as the natural log of E, what's the power on the E? 1. And then I know that logs and exponentials are inverses, so the answer is 1. Because they cancel each other out, and there's a 1. Okay, inverses. So these are explaining why it works out. Cancel. Cancel. Oh look, ln x, ln y. Same. Same.
Oh.
That's what they're saying. Now, let's put it in practical use. That might be more helpful, actually. 4a. Oh, look. In 4a, I see a log and an e next to each other. They're inverses. So my answer has to be 5. Oh, man. Second part. E and ln are next to each other. They're inverses. So
3.
3. I hope this isn't stressing you out at all. Oh, letter C. The ln and the e are not next to each other because the e is on the bottom of the fraction. So I'm going to rewrite it as the ln of e to the negative 2. And now the ln and the e are next to each other, and my answer is negative 2.
Smart.
Those rules are just talking about what you see up here. That's it. It's about, I'm sorry. I do have a hammer for later in case you're really stressed out. I just clunked it. Because that's what's left over after I cross off the ln and the e.
Because when you
Are you talking about why did it turn into a -2? Or why did I get that -2 as the answer in the end?
No, why did it turn into?
Because whenever you change position on a fraction bar, the exponent changes sign. Letter C. Doesn't work. Why not?
It's negative.
Negative. You can't log a negative. So I already know that this is no solution. So that's good. That's great. Uh-oh. Natural log of 2.3 and natural log of 0.4. I have no idea. Good thing there's a button on your calculator. Natural log 2.3? 0.8329. 3. You go to 3 decimals. Awesome. Natural log of 0.4.
-0.916.
Thank you. -0.916. That's it. Done. That's it. Yeah, stressful. Domain. What does domain mean?
X value.
The x values. So when I see domain, I better be thinking of my x values. You might remember that we did this with square roots. And when we worked with square roots, we knew the stuff that was inside of the square root had to be bigger than or equal to 0. Log works almost exactly the same. Almost exactly the same. Instead of saying greater than or equal to 0, you say greater than 0. So the x plus 3 is greater than 0, because it cannot be equal to 0. Move the 3 over, and I know that my domain is any number I want to choose that's bigger than -3. Like I can pick it in -2.9 is fine. -2 is fine. -1, 0. Any of those numbers will work. But if I pick -3, I'm logging a 0. No good. And the last one, I notice that inside of, or after the natural log, I see absolute value. What does that tell me?
Except for 0.
Very good, Christina. Because the stuff inside an absolute value is always going to be positive, I can choose any number I want to, except 0, because you can't log a 0. But even if I were to pick a negative number for x when I take its absolute value, I'm really going to be logging a positive value. So that's okay. I can't pick 0.